Objective for section 3, voltage sources. Voltage sources, woo, such as batteries and generators, supply energy that allow charges to move steadily. Charges do not flow unless there is a potential difference. Something that provides a potential difference is known as a voltage source. Batteries and generators are capable of maintaining a continuous flow of electrons. In a battery, a chemical reaction releases the electrical energy. Generators, like the alternators in cars, or maybe your family has a generator for when the power goes out, they convert mechanical energy to electrical energy. With the hand crank generators, that's exactly what's happening. You're turning the magnet inside, the magnetic field, and that turning of the magnetic field that you're doing with your mechanical energy of your arm gets converted to electrical energy. The electrical potential energy produced is available at terminals of the battery or generator. The potential energy per coulomb of charge available to electrons moving between terminals is called the voltage. So when you hear voltage or say voltage, what you're talking about is the potential energy per coulomb. Remember how many billions and billions of electrons there were in just 1 coulomb of charge? So imagine all of the potential energy there. So this battery here with a little nub on top, that's your positive terminal. That's the area where you have a much greater potential difference. And then the negative side, the flat side, is where there's a lower potential difference. So we would say the current moves from the high potential difference to the light bulb and then back to the lower potential difference to get charged up, to get more energy. The voltage provides the electric pressure to move electrons between the terminals in the circuit. So the voltage is like the pushing of those charges through that electron. I said I like to talk about water when thinking about electricity. So if you consider a river flows because there's a difference in height, right? Water up here is going to flow down and then it's going to pool down into a lake at the bottom. Well, the water symbolizes the current, so it's the flow. The difference in the height is your potential difference or your voltage. So the greater the potential difference, the stronger the flow, right? The same for water as it is for circuits. Power utilities use electric generators to provide the 120 volts delivered to your house outlet. So you have 120 volts of potential difference. The alternating potential difference between the two holes in the outlet averages 120 volts. When the prongs of a plug are inserted into an outlet, the average electric pressure, voltage, of 120 volts is placed across the circuit. This means that 120 joules of energy are supplied to each coulomb of charge that's made to flow in the circuit. The difference between current and voltage. Some confusion between charge flowing through a circuit and voltage being impressed across a circuit. So if we think about a long pipe filled with water, water is going to flow through the pipe if there is a difference in pressure across the pipe or between its ends. Water is going to flow from the high pressure to the low pressure, just like heat goes from high temperature to the low temperature. Just like air goes from a high pressure to a lower pressure. That's what creates wind. Everything goes from higher to lower. Charges flow through a circuit because of an applied voltage across the circuit. You don't say that voltage flows through a circuit. Voltage doesn't go anywhere. Remember, when you're walking around the circuit, you are the charge. The charges are the only thing that move through the circuit. Voltage doesn't go anywhere, it just stays. Voltage causes current. High potential difference to the low potential difference, causes current. Concept check. What are two voltage sources used to provide the energy that allows charges to move steadily?